Hello dear students, this is the one shot formula video for electrochemistry. So with this you can understand all the formulas and you can solve questions in simplest manner. Important. In fact, if you know these formulas enough to solve all the kind of numericals. Let's start basic charges and constants in this. Charge of an electron is 1.602 into 10 power minus 19 coulombs, indicated with E. Charge of 1 mole of electrons is nothing but 1 Faraday, which can be written as 1.602 into 10 power minus 19 into Avogadro number, thus for 1 mole of electrons. So it gives approximately 96,500 coulombs. This is generally used to calculate Faraday related questions. And gas constant is R equals to 8.314 joule mole Kelvin at 25 degrees Celsius or 298 kelvins. RT by F can write it as 0.0257 volt. So this is the RT by F value. Let's start the actual formulas of this chapter. Conductance and conductivity. Conductance, conductivity related formulas. Ohm's law, V equals to IR. Resistance, R equals to rho L by A. So here rho is resistance, resistivity. Rho is resistivity or specific resistance. A is area of cross section. And L is length. So R is directly proportional to length and inversely proportional to A. And R is, to remove proportionality, we are using a constant called as rho. It is constant for particular object, and this everyone know that Ohm's law, V equals to IR. I is current in amperes, R is resistance. Next one, conductance, which indicated with G. So G equals to 1 by R, which is nothing but reciprocal of resistance is called conductance. So that resistance units of resistance is ohm or mho inverse. So here units you can write it as ohm inverse because it's reciprocal. And conductivity, K equals to 1 by rho, which indicated as kappa. So rho, we already know that rho equals to RA by L. So this is about conductivity or specific conductance. And next is molar conductivity. Lambda m equals to kappa into 1000 by concentration or molarity. Same way, equivalent conductivity. lambda eq equals to kappa into 1000 by normality. So there is a relation between those two. Lambda eq into n factor or valency factor equals to lambda mul m. This is most important formula. And one more important formula here is very important, that is G into G star equals to R, kappa. So G into G star can write it as kappa, most important. Here G is nothing but 1 by R. G star is cell constant, which can be written as L by A. Very important. So G is nothing but 1 by R. G into G star equals to kappa, and G star is cell constant or L by A. So mostly questions are asked between these two formulas only. Hope it is clear until this. Next one. Applications of Kohlraa's law. So in that, application 1 under this, lambda naught m equals to lambda naught plus lambda naught minus. So it is the molar conductance at infinite dilution is sum of the ion contribution or sum of the conductance of ions. So second application is alpha, which can be written as DOD, which is nothing but degree of dissociation. So alpha equals to lambda m by lambda naught m. So this lambda m we can calculate with above formula, K into 1000 by molarity or concentration. Coming to next, very important is dissociation constant. Dissociation constant, we can write it as Ka, which can be written as C alpha square. So if you want that small derivation also, you can do HA, H plus A minus, and this is initial when time is 0, this concentration is C. Initially products are 0, and after some time when time is at T, so C alpha is formed, and C minus C alpha, we can write it C minus C alpha at time T. So Ka we can write it as products by reactants H plus into A minus by HA. So Ka equals to C alpha into C alpha by C into 1 minus alpha, you can write it, because this C into 1 minus alpha. If alpha is 5% or less than 5%, not equal to 5%, so we can neglect alpha value. So C alpha square by 1 minus alpha, can write it as just C alpha square. So this is the final formula which we get. That's nothing but dissociation constant. Here alpha we can get it from this only, DOD. So this is one more very important formula. Mostly they ask questions like this: find the weak electrolyte lambda naught value by giving equation or by giving other lambda naught values. Like by giving other lambda naught values, like NaCl is X and lambda m naught of HCl is some Y, and lambda m naught of CH3COONe is Z. So how to calculate it? Just we have to write the equation. CH3COOH plus NaCl gives rise to CH3COONa plus HCl. So what we can get here is, so this value we need to find by giving the remaining values. So this is Y, this is Z, this is X. So if you want this sum of the reactant values of lambda naught equals to product sum of lambda naught values. So if you want this, we can get z plus y minus x equals to lambda m naught of CH3COOH. So this is the final equation which we get. So this is basic application in most of the questions of this one. Hope it is clear. Next we'll start electrochemical cell. Electrochemical cell. So EMF of cell equals to E naught cell. Sorry, E naught cathode minus E naught anode. So you can write without naught because we are taking E cell, not E naught cell. So E cell equals to E cathode minus E anode. So here naught where it comes at standard conditions. So standard conditions are 298 kelvins temperature and 1 bar pressure. In old books actual standard condition is this, but in present books they are giving even 1 atm is standard condition. There will be slight difference, however it is you can take. So 1 bar or 1 atm, and concentration will be 1 molarity. E naught means just E naught cathode minus E naught anode. Otherwise also you can write the same. So E positive minus E negative. We can also write it as E reduction minus E oxidation. So this is about electrochemical cell. So here cathode values you have to take, then anode values, and how to represent the cell also important here. So cell representation is very simple. Anode first, then cathode. Middle two lines we represent, that's for salt bridge. So salt bridge is for just to prevent the liquid junction potential or maintain the electrical neutrality, all other things. So coming to Nernst equation, see I have discussed all the complete I have discussed in detailed way all the concepts including questions, everything. So if you want you can watch that full course of videos for electrochemistry chapter. So please like and subscribe so that it will be motivation. Anode and cathode. So Nernst equation is E equals to E naught cell minus RT by NF ln Q. This equation is nothing but Nernst equation, very important. This equation you will get it from the Gibbs free energy concept. So that derivation, if you want more about Nernst equation you can watch that complete video. So E cell equals to E naught cell minus RT by NF ln Q. Q is nothing but product concentration by reactant concentration. So E cell equals to or E equals to E naught minus 0.0591 by n log base 10 Q. So here n is nothing but number of electrons transferred during either oxidation or reduction reactions. So this is nothing but product ions by reactant ions, not solids or liquids. Pure either aqueous ions or metal ions can be taken to write the Q value. For single electrode, like M plus N electrons converted into M, this is reduction. So in this case how to write it is just E cell equals E half cell equals to E naught minus 0.0591 by N log product by reactants, but here product is solid, generally we'll write 1 for solids. So product is 1 and reactant ion is Mn plus. So E equals to E naught minus 0.0591 by N. Here what is 0.0591 value? RT by F into 2.303, because here we are writing what is ln. Ln equals to 2.303 RT. Sorry, ln we can write it as 2.303 log base 10. Hope it is clear. So if you substitute this into ln or RT by F into 2.303, we will get it as 0.0591. So this is the E equals to E naught cell minus 0.0591 by N, this one. So this we can also write it as E equals to E naught cell minus 0.059, you can write plus here, by N log base 10 M N plus. Why it is like that? Because if you send here, you will get plus. So based on the type of reaction, we can write whether it is reduction or oxidation. So we can write the Nernst equation according to the equation. So always products by reactants. But at equilibrium, what will be the result? So at equilibrium, what happens is E cell becomes 0. So what you can write it is E naught cell equals to 0.0591 by N log base 10 Q, you can get. Log base 10 K, because when E cell equals to 0, Q we can write it as K, because what is Q? It is called as reaction quotient. Reaction quotient is nothing but the concentration of reactants or products other than at equilibrium is called as Q, at equilibrium is called as K. That's how we can write K and Q as like this. So E naught cell equals to, this is the equation at equilibrium conditions. Even delta G equals to 0 at equilibrium. Hope it is clear. Now we will start the thermodynamic formulas, that is relation between delta G and EMF. So delta G equals to minus NFE cell, delta G naught equals to minus NFE naught cell. You can also write conditions for spontaneity. Delta G supposed to be less than 0, E supposed to be greater than 0. These are most important conditions. Delta G not equals to minus RT ln Q. This is also important formula. So you can write delta G naught equals to minus RT ln K. This is at equilibrium conditions. So you can write it here is E naught cell equals to 0.0591 by N log K, same thing. So if you want log base 10K, very important, what you can write is N E naught by 0.0591. So this is most important formula. So if you want K from this, you just write 10 power N E naught by 0.0591. Suppose if they give ln itself, then what we can see the difference. When they give ln, e power will come, e power x. If they give log base 10, that we can write it as 10 power x. So what I am concluding here is very simple and known point also. For the students who don't know, I am telling, base we have to send other side to get the k. Base 10 means this 10 will send here if you want just k. Hope it is clear. If ln is given, then you can take e power instead of x, instead of 10, sorry. So these are the next most important formulas now. Faraday laws of electrolysis. First law, W equals to ZIT. So Z is nothing but electrochemical equivalent. So electrochemical equivalent is nothing but mass deposited when 1 coulomb charge is passed. Charge is passed that we can also write it as 1 ampere current per second time is nothing but Z. So W equals to ZIT we can write. So there is one more term, that is E, equivalent, chemical equivalent, which is nothing but, so this is nothing but mass of metal deposited when 1 Faraday charge is passed on 96,500 coulombs per second time is nothing but chemical equivalent. So this is 1 Faraday, this is 1 coulomb, so we will make the relation between those two. We can write it as E by 96,500 into IT or Q. So according to this, W is directly proportional to Q, so that we are writing all these things. So W by 96,500, we can also write W equals to atomic weight by N factor into 96,500 into Q or IT. This is most important formula. Atomic weight of metal, you can write it here. So this is first law related, and still formulas are there for the same first law. So that is about current efficiency. Current efficiency, which you can write it as eta W actual by W theoretical, means mass of metal deposited actually by theoretical mass into 100. Here theoretical mass, how do we get is, this is the same formula which we use. So what we can get is eta equals to W actual, means actually what is deposited. Theoretical formula is IT molecular mass by N factor into Faraday whole into 100. This is same as this one or this one which we got above. Suppose if hydrogen gas volume is given, when hydrogen gas volume is given, then how do we do is, then what you will get is efficiency or current efficiency equals to actual volume by theoretical volume into 100. So this equivalence also we can find in simplest way. Equivalent volume equals to 22.4 by 2 for hydrogen Cl2 or F2, and equivalent volume for oxygen equals to 22.4 by 4, equivalent volume of N2 22.4 by 6. So this is how we can get the equivalent volume. For this shortcut and related things all I discussed very clearly in the videos, so just watch if you want. And coming to enthalpy of reaction, delta H equals to delta G minus plus T delta S, and delta G equals to delta H minus T delta S. Based on this, we can also decide spontaneity of the reaction, that is thermodynamic questions. Entropy from EMF and temperature relation, entropy and temperature coefficient relation. So temperature coefficient is equals to rate of change of EMF with the temperature, is nothing but temperature coefficient. So temperature coefficient you can write it as dE by dt, where E is nothing but EMF of cell. So units for this volt Kelvin inverse. So here you can also make some more formulas, and this area, this is little more high level syllabus, not for board or CET or NEET, just for JEE mains and advanced. So using this data we can write dE by dt equals to E2 minus E1 by T2 minus T1. If temperature coefficient is positive, reaction is endothermic reaction. If it is negative, exothermic reaction. So we can also write delta S by including temperature coefficient NF dE by dt. So here delta H can write it as minus NF into E minus T into dE by dt. These two formulas important for JEE mains and advanced questions. Let's see some additional points related to the concentration cells. Where the concentration alone different and material, the metal electrode remains same. In that case, E equals to 0.0591 by n log based on C2 by C1. Same way, E equals to minus 0.0591 into pH when H plus ion concentration is given. For SHC, we assume electrode potential value is 0. So this formula is important for all the exams, including board and everything. Suppose if pressures of two half cells are different, then we can get E cell equals to 0.0591 by n log P1 by P2. This is most important. So here, to be spontaneous for this equation, E cell, if you want to get more, E cell positive means spontaneous happens when C2 greater than C1. Here E cell positive when P1 greater than P2. So these are two important things. Based on this also JEE questions came. And also Latimer diagram. So Latimer diagram, what it tells, suppose M converted into M plus, that is converted into M plus 2. If they give this E cell value is some X, and if they give this E cell value is Y, so this is E1 and this is E2, you can write. Now they are asking what is the E cell value for converting M to M plus 2. In that case, we should not just add the E cell values. What you have to do is, we have to take delta G formula minus NFE. So based on the change in N value, means N is nothing but electron change, since M to M plus 1, so N is 1 in first case. Similarly second case also 1 only, but for this M to M plus 2, N value is 2. So delta G equals to minus NFE. So however, we will not take E value directly to get this conversion value. So you will take delta G, because E is not additive value, so that you should use delta G value. Latimer diagram. Based on this also, we can find whether the process is disproportionation or not, or whether process is possible or not, such kind of questions. This is also very important for NEET and JEE exams. This is overall what are the formulas there in electrochemistry chapter, and if you need complete chapter video, you can watch that complete course. Surely you will understand all things in detailed manner, and I also discussed questions with a lot of shortcuts, so don't miss.